Math 2, Unit 12A. Today we're doing Section 12.1B. So yesterday we worked through Desmos. We figured out like what's happening with these quadratic equations. We learned that they're parabolas. Do you guys remember the A values? The A values. So when this is in standard form right here, remember that the A value, what does the A value tell you? It tells you the width, if it's wide or narrow, so I'm just going to put width. And it also tells you the, very good, the direction. Okay, so today we're just going to be kind of going back and learning some of these things. And then you have it kind of written out more in words. So here's your quadratic functions. They can be written in multiple forms. Okay, there is something called the axis of symmetry. Okay, and we didn't talk about this yesterday, but what does symmetry mean? Symmetric, the same on both sides. And so how a parabola works is that if you were to like fold this over, they would connect, right? They're symmetrical. And so the axis of symmetry is the line of symmetry in a parabola. Your axis of symmetry or line of symmetry always goes through the vertex. It goes through the center of the parabola. Okay, sometimes it's through that 0 point. It just depends on where the parabola is on your graph. Okay, and so that line right there, that is your axis of symmetry. Okay, we also know that this point here at the bottom, that point is our vertex. Okay, the highest or lowest point of a parabola is its vertex. And it's always on the axis of symmetry, which tells you this here. There is going to be a minimum point if your graph opens upwards. Now, the reason why is because this is your smallest value right there. That's your minimum point. That's your smallest value because everything else is bigger. Does that make sense? Where if your graph is going down like this, that is a maximum point, good, because everything else is going down. Everything else is smaller. So graphs that go down have a maximum point, where graphs that go up have a minimum. Okay, so this question right here, it says, what is the vertex of the graph at the right? Is it a minimum or a maximum? So where, can anyone tell me the ordered pair for the vertex on this graph? Very good. So the vertex, I'm just going to write V, is at -2, -3. And would we say that point is a minimum or a maximum? Minimum is correct. And it is a minimum because this is the smallest point on the graph and everything else is going up. It's all above. Okay, so same thing here on number 1 and 2. And let's start with 1. Write down the vertex and whether it's a min or max. Okay, so what is the vertex? Good. Vertex is +2, 3. So it's going right 2, up 3. That right there is my vertex. And is that going to be a minimum or maximum point? Very good. Maximum because everything else is smaller. Now on this one, some of you might be able to look at this and know what's happening. If you don't, I would suggest just plotting those points on a graph to see what happens. So here one point is at 0, 8. I'm just going to mark that as 8. So 0 up 8. Then we have 1 up 2. And then 2, 0. 3, 2. And then 4 up here at 8. So if you can't tell what these are, you can just plot the ordered pairs. You can see that you have a quadratic function there. Notice here how like it has similar y values. That's your symmetric part, correct? And so on each side of the axis, they're going to have the same y value, but a different x. Okay? Now, what is my vertex? 2, 0. And is that a min or a max?
Min.
Very good, min, because everything else is larger. Okay, down here at the bottom, we have domain and range. So I just want to talk about what is the domain and what is the range. Does anybody remember domain and range back from Math 1? Very good. Domain is, we'll go ahead and write that, all the x values. So when you're looking at these parabolas, the x values, this right here is your x-axis, correct? So your domain is all the values on your x-axis. And if you think about this, if you have this parabola, as it keeps going out, it's going to keep spreading out wider and wider and wider and wider. Okay? If you have an equation for your parabola, which we would for any of them, you could plug in any x value and find a y value. Is there any x value that you could plug into like one of these equations where maybe you wouldn't get an answer? Is there any real number that you could plug in? The answer is no. You can choose any number and plug it in here and find the answer for y. So what that means is for your parabolas, your domain is always going to be all real numbers. Any number will work for your domain. Your range, those are all the y values. Now that will change for each parabola. So for instance, this one, all the y values are less than 3. There is no value for y that's above 3 because our graph's going down. Make sense? Okay, so we're going to go ahead and do some work with that. We're going to turn to the next page. Okay, so this one asks us to graph y equals negative 3x squared, and it also asks us to state the domain and the range. The first thing I would do on this one is draw your x-axis and y-axis, make it a solid line so we can graph this better. So wherever you choose to make your axes, that works. So if we're graphing this one, this is based on our knowledge from yesterday. We want to know our a value, which is, what's my a value for this equation? Negative 3. And since it's negative 3, what does that tell me? Is the graph going up or down? The graph is going to be going down. And negative 3, does it mean it's going to be wider or more narrow? More narrow. And you might want to go back and look at your notes, but it's more narrow. Now, one thing that I kind of think of, but it's not exactly true, is that you can almost think about this number as slope. And so if you were to write this as a slope like 3 over 1, you'd go up 3, right 1, and see how that'd make a more narrow point? I'll show you what I mean here in just a minute. So, and what's my c value? 0. Okay, so where will my vertex be? It's just going to be at 0. Remember that it would shift it up or down based on my c value, right? And so my vertex is at 0. We know our graph's going down and it's going to be more narrow. And what I was talking about the slope is if you go down 1, 2, 3, right 1, see how this makes a more narrow graph? So you can think of your a value as slope. Now these are not exact, those points I put on there, but it just gives you an idea of where it should go. Okay? So now we need to state our domain and also our range. So domain, what will my domain be? It's going to be all reals. And so you can either write out all real numbers like this if you want to. Do you guys remember the abbreviation for all reals? Yeah, it's the R, where you have like 2 parallel lines kind of like that, and then you put an R around them. That also means all reals. So either way, that works. And then, so does everybody understand that domains all reals, any x value I choose could work here in this equation and find a y value? Now, y's are a different story. Our y's, y, and then you're going to do an inequality. Is it going to be less than or equal to or greater than or equal to? Less than or equal to, because my graph is going down. So y is all values that are less than or equal to, and what point is that on the y? 0. So that is your range. Do we have questions about that before we move on? Okay. There are a few different types of equations that we've been talking about, or functions. A linear function is normally written in the form y equals mx plus b. That makes a line, correct? Okay, lines, you'll notice, they don't have any squared terms or cube terms. They normally just have plain x's and y's, or they could just have an x or just have a y. Quadratic functions are written in, there's two different forms they could be written in. The one we've been looking at so far is y equals ax squared plus bx plus c. Another form, I'm going to put or here, you'll see them written in, this is called vertex form, y equals a parenthesis x minus h squared plus k. No matter what, you'll notice in a quadratic function it has a squared term. Okay, then you have an exponential function. Exponential functions are written in this form, y equals a and then b to the x power. What you'll notice with exponential functions is that you have an x in the exponent. Okay, so determine whether the following functions are linear, quadratic, or exponential. So this first one. Very good, exponential. And how do we know that this is exponential? Very good, x in the exponent. Okay, next equation, what will that be? Linear. And one thing we can even talk about linear there is that there's no exponents. Okay, linear doesn't have exponents. Next one. Very good, and we know that one's a quadratic how? A squared term, very good. Okay, this one. And again, how do you know that one? Very good, squared term. Okay, next one. Exponential, how do we know that one is exponential? Very good, x in the exponent. And this last one. What is it? Linear. And we know it's linear because no exponents. In fact, maybe we want to add that to linear functions. No exponents. Okay, the last thing we're going to talk about is average rate of change. Just kidding, it's not the last thing we're talking about. I thought we have one more page after this. Okay, so average rate of change. A toy car is traveling up an inclined plane. Okay, so here is the toy car traveling. This is time, this is the distance it has traveled. Okay, it says estimate the distance the car has traveled at 1 second, at 3 seconds, and at 5 seconds. So I'm just going to write here 1 second, 3 seconds, and 5 seconds. So notice here's time. At 1 second, how far has the car gone? 5 is correct. And it's 5 what? Centimeters. Make sure you're using your units. So you need to pay attention. Along this line, it's going like 1, 2, 3, 4, right? But on this one, this is going by 2s. So pay attention to your graph and make sure that you understand what the numbers represent. 3 seconds went how far? Very good. 13 what? Centimeters. Good. Okay, and then we have 5, which is right here. And how far is it at 5? Very good. 17 centimeters. Okay, the next question says, what is the average rate of change from 1 to 3 seconds? Does anybody have any idea what we would do to find average rate of change? What are they talking about? you could do that, possibly. I wonder if that would work. Normally, average rate of change is dealing with like your slope, like what's happening between those numbers. Okay, and so what I'm going to do is I'm going to take, this is basically an ordered pair. So at 1 second, the ordered pair is 1, 5, which we got that information right there, correct? 3 seconds, it's at 3 and 13. Is everybody okay with that information? Okay, do you guys remember how to find the slope? Yes. How do you find slope? Good. So remember, slope is rise over run. So we're subtracting our y's over subtracting the x's. You just want to make sure you go in the same order. So I don't have to deal with negatives. I'm going to start with the second one. So we go 13 minus 5, because I'm subtracting my y's, over my x's, 3 minus 1. So 13 minus 5 is 8. 3 minus 1 is 2. And so I end up getting 4. And we're dividing numbers, which we have to also divide the units. And so it's y over x. So that means it's 4 centimeters per second. That is the average rate of change. That's what's happening there from those two numbers. Okay, so now it asks, what is the average rate of change from 3 seconds to 5 seconds? So what are we going to do for this one? Same thing, but we're going to take the numbers for 3 and also 5. So what's my ordered pair for 3 seconds? 3 and 13, and the other one is? Very good. Okay, so we always subtract the y's on the top, so that's going to be good. 17 minus 13 over 5 minus 3. 17 minus 13 is 4. 5 minus 3 is 2, so that reduces to 2 what? Centimeters per second is correct. So is the average rate of change changing? Yes. So the question says, does the average rate of change increase or decrease? And explain how the graph can help you answer this question. So first of all, is it increasing or decreasing as it goes in time? The average rate of change is decreasing. Good. So we're going to write average rate of change is decreasing and to help us understand the graph, I wrote something like the curve begins to flatten as time increases. So if you notice back here at the graph, as time goes on, see how it's like a shorter distance and it's going slower and slower? So that's what I'm talking about. Are there any questions here so far? Do you want me to say what I wrote again? Okay, average rate of change is decreasing. And then the second part is the curve begins to flatten, or a shorter distance, as the time increases. Anybody else have questions on that part? Okay. Going to the next page. This is our last page of notes, and then it'll start your homework. Okay, this says graph each function, then identify the domain and range. So we're going to get a little bit more practice with this. Again, I would draw my x and y axis. In fact, I'm going to do it for both problems here. Okay, so when we're graphing these right now, there are two numbers we want to look at, and what are those numbers? our A value and our C value. And on this problem, what is my A value? Good, -4. And my C value is 0. Okay, since the A value is -4, what does that tell me? The graph is going down and it's going to be narrow. Okay, where will my vertex be? At 0. Okay, so my C value is 0, so we're not shifting this any direction. Okay, and it's going to be more narrow. And so again, I kind of talked about how we could go down 1, 2, 3, 4, right 1. That kind of gives us an idea of the width of the graph, but it's not exact. Okay, so based on my graph now, what would be my domain? Domain are the x values, so what's going to be my domain? Good, all real numbers. So we talked about this earlier in that if any x value we choose and we plug it into the equation, it'll work. If you think about the parabola as it goes on forever, it'll keep expanding, okay? It'll end up getting wider and wider and wider, okay? Now your range is a little different. That is dealing with your y values. And so what would be my range on this? Good, y is less than or equal to 0 is correct. Okay, number 4. What is my A value here? Very good, 2/3. And my C value is 0. 2/3. What does that tell me about the graph? It's going to be wider. I'm just going to write wide. And it's also going in what direction? Up. Okay, since my C value is 0, where is my vertex going to be here? 0. So we're just, and if you were to go, again, think of this as like your slope, up to right 1, 2, 3. See how that's making it a little bit wider? So if you always think of it that way, it kind of helps you draw your width as well. Okay, what is my domain on this? All real numbers, very good. And my range is going to be what? Good, y is greater than or equal to 0, because this is where the y value starts, and then the graph is going up, so that means the y values are only greater. There are no y values that are less than 0. Question?
When is it not a real number? When are they not numbers?
When we have like imaginary numbers and stuff, that's not a real number. So when you're saying all real numbers, you're basically talking about positive and negative numbers, decimals. You're not talking about negative roots. So you have to say all real numbers, but it's basically talking about like your regular number system that you would always use. Okay? All right, and this we already have talked about this, but the coefficient, your A value, it doesn't matter whether it's positive or negative in terms of your width. Okay, and so you're always thinking about the absolute value when you're talking about width, and then the negative and positive just tells you your direction. Okay, and that's what they're talking about in this box. So these next questions, they would just want you to order these equations from from widest to narrowest. Okay, and so which graphs are wider? The ones with fractions, okay? The smaller the fraction, the wider it will be, okay? And then the larger the number, smaller or narrower it will be, okay? And so what would be my widest function here? Okay, f of x equals -1/3 x squared. That would be your widest function. Okay, what would be the next one? Good, f of x equals -x squared. And my third one would be f of x equals 3x squared. Good. Okay, again, we said that the widest is going to be your smallest fraction, correct? So do you see here how you have multiple fractions? Which one is the smallest? 1/4. So that would be our widest function. Okay, so on these, I'm just going to number them. So that would be number 1. What would be number 2? Good? And the third one would be our 5x squared. I'm going to give you about 15 seconds here to do number 6. Go ahead and number those for yourself. See if you can figure out which order. Okay, so what would be number 1? What is the widest? Good, the negative 2/3. So that's number 1. What's next? The negative 2, correct? So it's like you're almost going like your smallest number to your largest will give you the widest to smallest or widest to narrowest. And this is our third. Do we have any questions? Okay, these next 2 pages are your homework that you need to work on now in class. You will be turning in on Monday the entire packet. So I'm going to be making sure that you took notes today. So the entire note packet needs to be filled out for your homework, along with the homework completed on the last 2 pages. If you work hard in class today, you will earn a stamp on your paper. And I think that's it.